Sorry. I hope you can hear me at the back. I know the acoustics is a little poor here. I was asked to talk about challenges facing design professionals and specification writers and how to achieve a high return of investment from a roofing perspective. And wasn't really sure how I was going to approach that. What I did is, in the past, I've done these presentations to a number of OAH Ontario chapters about incorporating basic principles of building science to design a better quality, long-term durable, and based on life cycle costing, an inexpensive roof. So that's what you're going to see is just a summary of that presentation, slightly modified to address the issues of all the other keynote speakers. Okay. You may or may not be aware of the fact that the average life of a roof is decreasing, and I have a number of stats for that, or reasons. There's an overwhelming number of options today for design professionals and specification writers. It's estimated that there are over 30 modified bituminous membrane manufacturers in North America, and of those 30 membrane manufacturers, they have a combined number of 600 roofing membrane specifications or combinations, and that's just one small segment of the roofing industry. So of course you can appreciate and understand the complexity for a design professional trying to figure out which roof system to go with. Complexity of buildings is increasing. Roof warranties are written to protect membrane manufacturers. They're not, in most cases, there to protect you, the design professional, or your client. I am excited to hear Paul Hogaboom's vision for his, what he refers to as plain and simple warranty. Roof systems have this interrelationship, and I'm going to go into greater detail because I think a lot of design professionals don't understand or appreciate some of the nuances with the various systems that make up a roof assembly. Roof has this stigma. It's out of sight, out of mind. In fact, I've been in projects or involved with design professionals where we're talking about value engineering that roof at preliminary design stage. We're not addressing issues of differential durability. We're not looking at long-term durability. And the end result is we're not addressing issues pertaining to life cycle costing, which may be in the best interests of the client. Speed of building construction. I think we would all agree that this is really changing how we do business. Time is money for the industry today. I've stated here, architects' knowledge is decreasing. It's not a reflection that architects are getting dumber, far from it. What it is all the issues I've just previously addressed, it's getting more and more complex. And we're only talking a small segment of the entire building envelope. The end result is there's a greater reliance on manufacturers. I can only speak for myself, but as a young sales rep involved in roofing, I just wanted to sell anything. So I typically sold the lowest common denominator. Now, as I've matured and gained the necessary experience, you start to ask the questions, how do you define differential durability? How do you look at longevity? What is the intent of this building? What are the occupant use inside? What is the relative humidity? These are issues that only through experienced sales reps do you get the necessary information to address the issue. I've stated here that litigious societal trends attract creative attorneys. That's predominantly in the United States, but we're seeing it more and more as a common occurrence here in Canada. And then last I've stated that roof industry is collectively becoming complacent. And let me give you some examples of that. Probably the most recognized architect by name in the 20th century from a consumer perspective is Frank Lloyd Wright. So Frank was once asked, why did every one of his buildings leak like a sieve? And he said, listen, if my building isn't leaking, then I haven't stretched the boundaries of my design enough. And I'm going to give Frank a pass because Frank was designing buildings in the mid-1890s up until the 1950s. He was designing buildings that had a lot of horizontal, vertical movement. We were producing products like coal tar pitch and raw, brittle asphalt that was incapable of bridging the types of movements that Frank was designing for. The roofing industry collectively started to develop thermoplastics, thermosets, rubberized asphalts, and even felts that contained fiberglass or polyester reinforcement scrims. And the end result was that the roofing industry came to the table and was capable of designing roof systems that could accommodate the type of movement that Frank's buildings were accustomed to, and for that part, most buildings of the 20th century. Unfortunately, now we're in the 21st century and we have architects like Frank Gehry that have raised the bar yet again. In fact, the StatHub Center in Cambridge, it had been involved in litigation from 2007 to 2010 over a number of issues. One of the key areas was due to moisture migration into the interior of that building. I'm going to quote Robert Campbell, who is a local architect and a journalist, and he said, "It is inevitable that there will be problems with any unconventional building, such as a Stata Center, which has roofs that are colliding at different odd angles. But the client accepts the risks because they get a building like no other building. Name another industry where you can have a very select and unique group of design professionals that say, I want my buildings to leak, and then even have clients that are prepared to pay to have a roof leak. We're very isolated and unique in that field. In fact, I'm being somewhat facetious. This is the most important slide that I can present today. It seems to be a slide that most people don't seem to care about. But in fact, roofing represents less than 10% of the cost of any building, but is an issue in roughly 80% of all construction litigation and 10% of all professional liability claims. In fact, DPEC, which is now XL Group of insurance companies, DPEC did a research and they said roofs were the single element most often involved in architectural claims. And in fact, on their report on focus of claims, they identified some key issues that were continuously being identified as areas of litigation. And they don't total 100% because some of these were done multiple times. But 50% of all roofing litigation that they were encountering involved roof flashings, inadequate field observation, and lack of a high-quality roofing contractor. And there's issues that we can address to get around that or prevent that or reduce that liability. But 1 in 4 design professionals were specifying new and proven materials and technology. 1 in 5 was due to design error, and close to 1 in 5 are doing field changes without the architect's knowledge. And another report that was published in Architectural Institute in 2011, they state that roofing liability accounts for almost 70% of all forms of litigation. And they identify some key issues as well. They identified certainly improper installation, inadequate details, lack of attention to specifications. And I'm referring to mostly independent architects that don't focus in on their specifications. They found that most of the specifications were outdated, they didn't meet code or current code requirements, and they were reusing a boilerplate specification. In other words, they kept regurgitating the same error over and over and over again. They also identified that specifications of 10 years or older, almost 50% of them had referenced membrane manufacturers or some type of roofing product that didn't even exist. And of that, 35% of the products that they identified were unrecognizable. So I'd like to just bring you back to the first one, improper installation. No wonder these contractors have a difficult time because the specification isn't identifying products or systems that are even on the current market today. Now I'm going to bring you up to the Carl Cash study. It's another slide I love to present. I know I get chastised by a number of people in the roofing membrane profession because it's a somewhat dated slide. It's about 15 years old. I like it. And the reason I like it is it was an independent report, not subjected to some single-ply or modified roofing company sponsoring it. Carl Cash is a well-respected consultant. And what you're seeing here is I've highlighted 15 years because in the province of Ontario, I believe that's your errors and omission insurance. And the majority of single-ply roof membranes are identified. In fact, SPRI, the Single-Ply Roofing Institute, identifies 3 types of single-ply membranes. They identify thermosets, which are EPDMs, thermoplastics, which would be like PVC, TPOs, and modified bituminous membranes. Now, who would have thought mod bits are classified as a single-ply? They've been that way for over 30 years. You have to realize and appreciate we're mopping down a base ply and we're torching a cap ply on top so it becomes monolithic. The average life of a single ply membrane, based on the Carl Cash study, is about 15 years. If we added 1 additional ply, so we're going 3 plies, we could go 4, we could go 5. When we start going beyond 5, we're actually probably bringing less of a return on our investment. But we can increase the longevity by 30% by just adding an extra ply. Because contractors, we're encouraging them to be redundant. Use the redundancy factor. Just for the record, the green is sprayed urethane foam. Okay. So how does one measure the manufacturer that you want to even get involved with? Tremco directed me to Arizona State University, where they've been involved with the university for the last, I'm not sure, I think it's over 5 years certainly. And what the Arizona State University does is they act as a third party and they interview owners of buildings that have been completed. And based on this report, it's difficult to see, I believe it's over 35 million square feet or 38 million square feet have already been evaluated. And what is so surprising, and I'm going to have to yell because I can't even see it from here, is they've broken them down into categories. So if you're a specialist in school design, you can ask to look at the report on schools. But what we're seeing here that I find fascinating is they look at percentages. So it's customer satisfaction, 93%. Percentage of customers that would use Tremco product again, 99%. Return of value, 89%. Customer satisfaction of the Tremco rep, 95%. This allowed, from my perspective, allows us to have a variable that we know that this is a proven track record. In fact, Tremco is even now, Arizona State University is looking at it from a 5, they'll be looking at it from a 10-year perspective. But now we have independent third-party confirmation as to a manufacturer's ability to do what they say. Now I'm going to talk about differential durability. Professor Ted Kessick, who's a keynote speaker, introduced me to differential durability, and it's talking about interrelationships between materials. The definition is that it's a term used to describe how the useful service life of a building and its components, how they work within themselves and even between themselves. So I took differential durability and I looked at it from just a roofing perspective. So there's a group of segments here. So for example, we look at material expansion coefficients. One area we may wish to look at is polyisocyanurate foam, which accounts for 95% of all roofing systems. It's published that on a routine basis, you can expect a 3/4 inch movement of polyisocyanurate foam insulation. Imagine what the effects are on a modified bituminous membrane or a single ply or a built-up roof. We have to properly design to accommodate these types of movements. We have to look at such things as environmental issues. We historically have always visualized that roofs blow off as a direct result of wind blowing over the parapet, creating negative pressure, uplifting the roof. The National Research Council has said, well, I think another very key component to that is air intrusion from the underside. In fact, we have a new code requirement that's being introduced that will address that issue specifically. Historically, we associate it with single plies like thermosets, thermoplastic membranes. But after Hurricane Juan hit Halifax, this is an example of a 2-ply modified. So it's not just isolated to what we would typically associate with true single plies. And in fact, on this slide, you can see that there's a cohesive failure of the raw brittle asphalt. And in fact, when we talk about warranties, and I'm not here to get into that discussion, but I always find it surprising. A number of key membrane manufacturers will say our warranty will not be void, or will be void if the winds exceed gale force. Well, gale force on the Beaufort scale for wind speed starts at 25 to 31 miles an hour. I think we had 2 days last week that exceeded that wind. So we have to be careful when we look at these types of problems, what caused them, who is liable, if anyone is liable. Heat transfer. We're all familiar with SB 10. It's now an Ontario code requirement. SB 10 addresses issues, and I'll paraphrase. If you go with the prescriptive method, you're looking at 40 to 60% window wall ratios. You need R18 in a wall and R30 in a roof. If we go with the basics with a system, this is published in the Roof Consultants Institute, a respected magazine. They're trying to achieve an effective R value of R20. We can put down 2 square feet of fasteners to hold down the board. We can install the membrane. We assume a 1/2 inch gap, which is routine. To achieve an effective R value of R20 for this type of a system, you've already installed 3.2 inches of polyisocyanurate insulation. You would need to install another almost 3.5 inches to achieve an effective R value of R20. So we need to be able to understand how can we improve the thermal performance without compromising cost and durability. We have to look at UV degradation, or ultraviolet degradation. Asphalt, when exposed to sunlight, becomes very brittle and oxidizes. And what we need to do is, and I would suggest that everyone be considering this for any project instead of using raw brittle asphalt, is the use of SEBS rubberized asphalts. They have a very high tensile strength, which is great on the field of the roof. because it helps to stabilize all that movement that we are anticipating. It has phenomenal elongation, great for flashing details around curves, and of course it has a cold weather bend. The only concern I have is there's been a number of manufacturers that are slowly but surely cheapening the use of the product to a point that we're not sure of if we're comparing apples to apples. So you have to do your due diligence to verify, am I comparing product A and product B, and are they meeting the same performance criteria? Galvanic corrosion, we need to understand that if we're going to specify the right roofing products. You may go with pressure treated wood, and if that's the case, you need to go with corrosion resistant fasteners or preferably stainless steel fasteners. But if those fasteners are going to be used in conjunction with a metal counter flashing made of aluminum or galvanized steel or galvanized metal, you're going to have an acceleration of corrosion and deterioration. So you need to have an appreciation and basic understanding of those issues. Solvent attack. You may not be aware, but animal fats have a profound effect on many of the roof membranes that are used. So you just can't use your boilerplate specification, print out the same product with the same roofing material just because it worked on your previous job. You have to look at each project individually. There are systems that we can utilize that, for example, that will address animal fat so that it won't cause deterioration. But this we would have to look at from even from an industrial perspective. We also have membrane performance. We talked about the amount of movement that polyisocyanurate will exhibit, even when mechanically attached. So we should be looking at ASTM standards for tensile load strength to help stabilize the field of that roof to prevent all this movement and deterioration of the roof membranes. We have to look at, no, you can do that. I wasn't going to talk about that. That was supposed to be deleted. But anyways, if you're looking at ASTM, you have to address issues of thermal shock, moisture aging, you've got deflection of your roof systems. And again, by incorporating a good ASTM, Yep. Oh, and the last is sustainability. We typically acknowledge that as from a white roof perspective, and Ted Kessick said it best. You know, it's part of the LEED program, and I think what we should be looking at is what is our waste? How many times are we removing this roof system and sending it to a dump? It's admirable that we all want white roofs. It's probably not financially viable to have a white roof here in Southern Ontario. There's a lot of third-party research to verify that, but I understand we have to get our LEED credit. But if we're going to do it, we need to look at doing roof systems and solutions that can meet the long-term durability that we don't have to replace. I'm hoping Chuck Fitzgerald will talk about that in greater detail. I was always brought up with the knowledge that, and I believe this, that most design professionals have a strong understanding of wall design. And I keep saying to an architect, and I say this to the students that I'm involved with, if you understand how to design a wall properly, if you put it on its side, you can design a roof. Unfortunately, I'm usually talking about the inverted or upside down or IRMA roof system, where the air vapor barrier is all on the warm side, makes it for an easier design. But typically 80% of our roof systems incorporate a conventional roof where we're actually using a double vapor barrier. Nowhere else do we do in a building envelope do we install a double vapor barrier. So we need to be able to understand and appreciate that. But if we're going with the inverted roof, I don't know why it is, but more and more people are going with roof systems in an inverted configuration. For example, a mop-based torch cap. If I take that principle and apply it to the definition that the National Roofing Contractors Association and just recently the CRCA, Canadian Roofing Contractors Association, have provided clear definitions of what a waterproofing membrane is and what a roofing membrane is. A waterproofing membrane is there to prevent hydrostatic buildup, an exertion or a force on water to allow it to migrate through the membrane. Waterproofing membranes are designed for the presence of standing or ponding water. Roof membranes are different. They provide water impermeable coatings, they provide weatherproofing characteristics, they're designed for short-term hydrostatic pressures, and they're not generally designed for the presence of standing or ponding water. Why would I use, as an example, a 2-ply modified, which in many instances, historically speaking from a warranty, the presence of water on that roof after 48 hours, the warranty may be null and void. Or many of them now use a very vague term, we want positive slope to drain. Why would we be incorporating that in an inverted configuration? What we should be looking at is a true waterproofing membrane that addresses the definitions of allowance for standing or ponding water. So I want to just leave you with a last quote. This is by Peter Green. Roofing may be one of the least rewarding aspects of an architectural design program, but it deserves undivided attention because it can become the most conspicuous, I can't even say it, of the program's shortcomings. I don't know if there was another one. Talking to John Campbell, and I think this ties it into the whole presentation. Perpetual roofs are achievable with sound products, technical knowledge, and on-site support. So I thank you.
Perfect.
Wow, good one time.